Hi everyone, here's the second video on the table function. I pulled a problem from college algebra here to illustrate this because this is typically where I demonstrate this when I teach that course. We're going to find the rational zeros of the polynomial p of x equals 2x cubed minus x squared minus 7x plus 6. So remember that the possible rational zeros are given as follows. These are going to be the factors of the constant over factors of the leading coefficient, which I'm just going to abbreviate LC for short. So notice that this is going to be some combination of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1, comma, plus or minus 2. And notice that when I simplify this, this gives me plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus a half. 2 over 2 is 1, and plus or minus 3 halves. So traditionally the way this is taught is that you use some sort of technique to narrow this down if possible, and then use synthetic division to see if in fact we get a zero remainder. But in the age of technology, those techniques are a little outdated, and we can actually use the calculator to speed things up. But notice that these numbers don't come in any particular pattern. All the integers, that's easy enough. They're all one away, but then we got the halves, and we could set our table set size to a half. But also notice that we'd be looking at values ranging from -6 to +6, which is a lot of things to check. And we're only interested in these things and not everything in that range of numbers, even if we set the step size to a half. So instead, what we're going to do is we're going to change one of our options. So what I want to do is I'm going to go over to my calculator, and I'm going to punch in this equation here. So this is going to be 2x cubed, so 2x cubed, and remember to bring your arrow down, minus x squared minus 7x plus 6, and I hit enter. Now before we go to table, let's go again to table set, and this time we're going to set the independent to ask. And now, since we set independent to ask, we do not have to worry about table start or delta table, because now when we go over to the table function, we're going to be able to plug in our own numbers. So go to second table, and notice now that everything is blank. And what happens is that I have this one screen, and apparently we're not allowed to move up or down until we punch in numbers. So I'm waiting for the calculator to catch up. I think it has. So we said plus or minus 1 are possible solutions, so I can type in -1, and notice that -1 will give me a 10, so let's look at +1. And in fact, +1 is a 0, so quickly right away I found one of the zeros. And then we can just continue on. So we'll have -2 is also a 0, so that's good. I found 2 zeros, and this is a degree 3 polynomial. 2 of the roots are real, so the third one better be real as well. So, but +2 is in it. So let's look at -3, +3. Those do not work. -6, +6. Those aren't zeros either. And so now we just go to our fractions. So we'll have a half, -half, and notice that I turned the fractions into decimals. Those didn't work, so let's try. The only disadvantage here is that I do not think you can scroll up or down. So -3 halves don't work, and in fact I cannot scroll down, so you just have to overwrite something. So the only one we haven't tried is 3 halves, and that's our other zero. So notice our zeros are 1, -2, and 3 halves. So let's see, so x equals 1, x equals -2, and x equals 3/2 are the zeros. And actually they are rational zeros. So notice that this function allows you to evaluate a function for multiple values very quickly. If they're all like if you want to evaluate every integer, you use the function like in the first video. If you have to just do a bunch of random numbers, this technique in this video is the much better approach. So next we'll have trying to find functions in our viewing windows. See you then.